In this video, we want to talk about condensate. Now, we all know that condensate is produced when we remove humidity from the air in air conditioning, or sometimes when we have a condensing furnace that's a high efficiency furnace that creates water as it removes heat from the flue gases. Okay, but let's talk about air conditioning pretty much in this video. So, we know that the idea is that we take the water, we put it in a drain pipe, we send it outside. But there's actually much more to it, and there's reasons why condensate flow doesn't always work. But before we go there, let's just do a real quick review of airflow and static pressures. We have to understand positive pressure, we have to understand negative pressure, and we have to understand neutral pressure. And we also have to put this into play with how different air conditioning coil configurations are affected by this pressure. This all goes into proper condensate removal. So let's start off with the basic air handler that someone might have in an attic. This is a horizontal air handler. Return air is on the left. Supply plenum is on the right. We have a blower and we have an indoor panel. Now in this configuration, our indoor coil and thus our condensate is on the negative pressure side of the system. It's before the blower motor. Okay, and that's a very important point. We'll get back to it later. Okay, in a horizontal system, when the coil, the evaporator coil, okay, is on the before the blower towards the return plenum, that evaporator coil is on the negative side of the system. This is an upflow air handler. Again, the neutral point of the system, the point of pressure change, is the blower. So our indoor coil and our condensate is on the negative side of the system. Now this is where we change. This example, you'll see that our coil is more towards the supply plenum. It's after the blower. Our condensate line is on the positive side of the system. This makes a difference. Okay, because our negative side of the system is sort of a vacuum. It's pulling air. Positive side of the system, it's pushing air. So this all makes a big difference on how our condensate lines and our condensate flow occurs. This is a downflow furnace. In this case, our indoor coil is on the positive side of the system. It's closer to the supply plenum with respect to the blower. And thus our condensate line is on the positive side of the system. Okay, airflow configuration does equal condensate requirements. Airflow configuration affects what is required for proper, safe, and complete condensate disposal. What do we mean by this? Proper condensate disposal means no pooling of water in the air handler or drain pan, no water in overflow pans or emergency drain pans, and proper drainage from the lines. We don't want to have any leaks in the appliance areas. This could be the attic, the basement, the crawl spaces. We don't want any backflow into appliance. In other words, I don't want any water being sucked back or running back into the air handler or the area with the coil if it's over a furnace. I don't want any sweating of the cold condensate lines to cause property damage. If I run a condensate line without insulation through a hot wall or a conditioned space that's warmer than the condensate line, I'm going to have condensation build up on the outside of that line. It's going to cause property damage eventually. So what does building code say about condensate? International Mechanical Code, IMC, addresses condensate disposal, piping, requirements, traps, etc. in Chapter 7, Section 7, and it starts with Area 1-2.5. IMC goes through pipe sizes, slope, and minimum standards. Again, minimum standards. This doesn't mean that you need to do the absolute minimum. If you can do greater than minimum, your customer is going to be better off. There's a few important points of International Mechanical Code that we do need to highlight. Section 307.2.1 requires a 1% horizontal slope from the drain pan to the discharge. In other words, water runs downhill. 307.2.2 references plumbing code, which requires minimum drain line size of 3/4 inch inside diameter. In other words, you can't use 1/2 inch pipe for condensate unless it's pumped. 307.2.3 requires a water detection device that will shut off the equipment in the event of a primary drain line being clogged. In other words, we don't want the equipment to continue to run if the drain line's clogged, because all you're going to do is dump water where you don't want it to go. 307.231, for downflow appliances, the shutoff safety switch needs to be installed inside the primary drain pan. May not be in the primary drain line. In other words, you can't put a switch into the primary line on a downflow appliance. 307.2.4 talks about traps. And this one is extremely important. Condensate drains shall be trapped as required by the equipment or appliance manufacturer. That's what code says. Okay, condensate drains shall be trapped as required by the equipment or appliance manufacturer. This means that you actually have to find the manual that talks about condensate lines and traps. Okay, you must follow the manufacturer's requirements from the installation manual. So when we take a look at a horizontal installation, we can look at this picture. What's wrong with this installation? What side of the system is positive? What side is negative? What does the manufacturer say? Okay. We know the coil's on the right side, but do we know where the airflow is? Okay. My blower is in the blower housing right here. Okay. In this case, I can tell you that the airflow, the airflow from this system is going from right to left. Okay, this coil's on the negative side of the system. What's wrong with it? There's no trap. Okay, we have a safety switch here. That's great, but there's no trap. Notice the rust and discoloration around here. This system's been dripping. So if we take a look at the data plate, okay, we find out that our manufacturer is Goodman. I did block out the serial number for privacy's sake here. Our model number is ASPT37C14AC. So you want to find the installation manual. Easy. Do a quick Google search. Okay, you can Google search anything and you can most often find the install manual someplace. Okay, so find the PDF installation manual. The install manual normally covers multiple models, so make sure your model number is listed. Now, the model number that's listed will not include the entire numbers. Okay, so in this case, ASPT37C14AC. All of this may not be part of it, but you want to find the install manual that says ASPT, there's a asterisk 14. Okay, this includes our model number. Make sure your model number is part of what's listed on the install manual. Find the condensate information. In this case, it starts on page 10. So we go to page 10 and we take a look at what it says about condensate line. Okay, so the coil has a primary and a secondary drain with a 3/4 inch NPT female connection. Okay, either PVC or metal pipe should be hand tightened. Okay, if you over tighten these things, it's going to break the drain pan. And it tells you exactly how far the line should be put in there. It says ensure the drain pan hole is not obstructed. To prevent potential sweating and dripping on the finished space, it's necessary to insulate the condensate line located inside the building using Armaflex or a similar material. In other words, if you run your condensate line across an attic floor, inside a wall, or any place where if there's drippage or sweating from the line, that's going to cause damage to walls, insulation, sheetrock, or anything else. It has to be insulated. The reason for this is simple. The water in that condensate line is going to be much colder than the area around it. It's like taking that glass of water and setting it on a kitchen counter, the ice water. Sooner or later, you're going to walk back over and find a puddle of water around the bottom of the glass of ice water. This is what happens in an attic environment or inside a wall. You don't want that to happen. A secondary condensate line has been provided for areas where building codes required, saying pitch all drain lines a minimum of 1/4 inch per foot to provide free drainage. That goes along with the code. Provide required support to the condensate line to prevent bowing. In other words, we don't want it to sag. If a secondary line is required, run the line separately from the primary drain and end it where the condensate discharge can easily be seen. That's our overflow line. Because water coming from the secondary line means the coil primary drain line is plugged and needs immediate attention. And then it says, caution, if a secondary drain line is not installed, the secondary access must be plugged. This is because it's going to suck air. Remember, this coil's on the negative side of the system, which means it's going to pull air into any opening that's not properly plugged. Okay. Insulate drain lines located inside the building or above a finished living space to prevent sweating. Install a condensate trap to ensure proper drainage. Remember what our code said about the condensate traps? Required. When units are installed above ceilings or in other locations, it is mandatory to install a field fabricated auxiliary drain pan under the coil cabinet enclosure. Manufacturer's installation instructions are all referenced in code. So if it says it in the manual, even if it doesn't say it in code, you have to do it. The installation must include a P-style trap that is located as close as practical to the evaporator coil. Now this one is one that we hear a lot about. Okay, if you are installing an existing condensate system, and if you think there might be another trap or another low point in the system, it doesn't say you can use that, okay, because you're not 100% sure it's there. Okay, and it also has to be as close as practically possible to the system. It doesn't say under the foundation. It doesn't say use the loop that goes under the foundation as a trap. It says as close to the system as possible. Units operating in a high static pressure application may require a deeper field constructed P-style trap than what is shown in Figure 12 to allow drainage and prevent condensation overflow. Okay. Here's what we mean by a trap. You have a drain connection coming out of the air handler. Okay, this is a P-trap. Okay, so we come down a minimum of 2 inches to where we're even with the outlet. The trap, or the bottom of the trap, is a minimum of 3 inches down. In other words, 5 inches total down and then back up 3. This water that collects at the bottom of the trap prevents air from being sucked back in here on the negative side of the system. Okay, because this is in a vacuum. That area with the drain connection is in a vacuum. So if I didn't have the trap, it is very possible that condensate would be sucked backwards into the air handler and through the blower or out of the drain pan and make a mess up there. So this is why a trap is required. It allows the condensate to drain without having to run against the air that could be being sucked backwards into the coil. Trap lines are required by many local codes. Okay, in the absence of prevailing local codes, please refer to the requirements listed in the Uniform Building Code, okay, which is basically similar to International Mechanical Code, but by a different organization, okay? But most states are following either Uniform Mechanical Building Code or International Mechanical Code. Both of these codes reference manufacturer's instructions. A drain trap in a draw-through application prevents air from being drawn back through the drain line during fan operation, thus preventing condensate from draining. Okay, if it's connected to a sewer line, Okay, the trap will prevent sewer gases from being drawn into the airstream drain blower operation. Use of a condensate removal pump is permitted. Okay, you might not have natural drainage. You might drain into a condensate removal pump. A trap has to be installed between the unit and the pump. The evaporator coil is fabricated with oils that may dissolve styrofoam and certain types of plastics. You have to use a removal pump that has a float switch that does not contain styrofoam. Okay, what do we mean by high static pressure environment? When we look at the label, okay, this data plate of the air handler, in this case it's 0.5 inches, okay, water column, test external static pressure. Anything over that is considered a high static pressure environment. The chart above is found in the installation manual. Okay, it gives you the model number. It gives you the blower speeds. In other words, T1, T2, T3, T4, T5. Those are taps on the blower motor. And it tells you at what airflow you're going to hit 0.5 inch static pressure, or better yet, the other way around, your airflow for 0.5 inch static pressure. Okay, in this case, we're on a 3-ton unit. I know that I have to have a minimum of 400 CFM per ton. So a 3-ton unit, I'm going to have 1,200 CFM of air. Okay, in order to have 1,200 CFM of air at 0.5 static pressure, okay, I have to be on blower taps either 4 or 5. Okay, so, but anything over 0.5 inch static pressure, if I measure static pressure, I'm in a high static pressure environment, so I may have to go with a deeper trap. If you remember back a few slides, we talked about that. Okay, here's a couple trap examples. These are from rooftop units. These are just bad trap examples. Okay, here we have someone who manufactured a trap but left the bottom of the T unplugged. Okay, so in other words, this whole trap isn't working because water's just dripping out the bottom. In this case, it's actually sucking back and it's dumping it down the return plenum, which is making a mess in the building below. This is another trap where someone did do a clean out here. Okay, this is a removable cover down on the bottom of the right-hand one. It's closed, it's covered. Okay, so this trap actually works. Now they did this because in the winter, this is in a cold environment, they want to be able to drain the water out of that trap. Now, there's another term you're going to hear occasionally, okay? A normal trap installation will drain properly and prevent backflow into the evaporator coil drain pan. In this little diagram, this is just a quick diagram of a trap. My air handler's on the left-hand side, my outlet's on the right. It's dependent on maintaining this proper pitch, okay, all the way to the point of discharge. In other words, this line should be coming down 1/4 inch per foot, okay, all the way to the point of discharge. You can occasionally run into a double trap condition, okay? If this discharge line either sags or goes under a foundation, okay, or has anything that you're unsure of where it goes, we could end up with a double trap situation. Now, why is double trap so bad? This area between the two traps, okay, let me get a pen here. This area between the two traps, this area here, can get an air bubble in it. And the water will not be able to push that air bubble out. That air bubble is going to stay in the highest point and it can block the condensate line. Okay, so in other words, if this line here, if you're coming out of your air handler, you do a trap, okay, you come over to a foundation wall, your condensate line comes under a foundation and back up to outside and comes outside on the other side of the foundation. This area here is a double trap. Okay, you don't know the condition of this line. Now, you might be thinking, well, I'll just leave that extra trap. I'll just leave the first trap out. You can't do that. manufacturer's directions say as close to the air handler as possible, and a lot of code officials are looking at this these days. Okay, you want the trap to be up here because there's a lot of water and everything that can still be sucked back. So we have a solution to that. What you do, okay, is you add an air brake. An air brake is just a T with an open pipe to the air after the P-trap and before any possibility of a second trap. Now what this does, it prevents that air bubble or vacuum from forming in the pipe, preventing water flow. Okay, because my air has now access to outside air, because we always want air behind water. So I'll get here, and this air bubble here will now be able to escape as water tries to push its way through. So it's not going to create a thing. Now, the key is this pipe cannot be covered. Okay, I've actually seen people put these in and put a cover on the top of it. You cannot cover the pipe. This must be open to the air. The T should be 3 to 4 inches taller than the primary drain pan connection. In other words, if my drain line gets clogged up, I don't want all the water to be running out of that. The open end of the pipe should not be sealed. It must have free air movement. That's an air brake. It's after the P-trap. Okay, if you're unsure in any way of what your condensate line is from the point of the trap to the outside, you want to put in an air brake. Air brakes are always open, always on the discharge side of the P-trap. Okay, air brakes on the discharge side of the trap can also be considered cleanouts because you can actually use this to clean out the condensate line and help clean out the trap. Okay, if you stick a vacuum on here, you can actually pull the water and gunk out of this trap into your wet dry vac. Cleanouts. Okay, something that's designated as a cleanout can be found between the drain pan and the P-trap. Cleanouts must be covered and airtight. That's because, again, if this system's on a negative pressure here, okay, I don't want to pull air down through there. So we have to cover these, and they must be airtight. Cleanouts are specifically used to provide access to clean out the trap and the drain pan connection. Okay, so again, we have an air brake that's after the trap, and we have a clean out that's before the trap. The air brake is never covered. The clean out is always covered. Any deviation to the requirements of code or the instructions in the installation manual is going to be improper installation of the condensate line. Improper installation will cause property damage. An improperly installed condensate line in a humid environment can dump 25 to 50 gallons of water per day into the building. An improperly insulated condensate line can be constantly dripping water into areas of the building you may not see until you start seeing the evidence of mold, moisture, sheetrock damage. All of these can cause severe property damage. In other words, don't be that guy. You don't want to be the guy that has the reputation for not installing lines properly. Take the extra time, put in an air brake if you're unsure at all of your trap or slope of the pipe or anything else. Put in the P-trap by the piece of equipment. Okay, don't be that guy.